All righty, so this is going on page 57 when we're done. Okay, so just like yesterday with the compositions, inverses are not brand new to you. Okay, so you can't approach them like you've never seen them before in your life. I mean, I'm going to kind of go back over some of the basics, but you still have to have some general understanding of this. So an inverse relation will undo a given relation. Okay, now this is called inverse functions, but we're talking about relations. So something that is not a function is a relation. Well, I guess honestly, they're all relations, but function's like a better name. So if it is not an actual function, let's say that it looks like this, and this wouldn't be a function, but I could graph it, then that would be a relation because we're relating an x value to a y value. But that would not be a function there. All right, so every inverse relation can be found by switching it's kind of a long word for a short box, switching each x and y value, or each input and output. You switch the input and the output, you have your inverse relation. Okay, most of the time we're going to switch x and y, and then we solve for y again. Right, but I mean it's still an inverse even if you don't do that. All right, so in some situations this process is intuitive. Do you know what that means? That means it makes sense. Okay, most of the time it just totally makes sense but what to do, but other times it may not be as obvious. In these cases it is important that we understand the concept of inverse relations, as they will help us tackle a variety of problems. Okay, so conceptual understanding is very important. Just being able to go through the motions and do the steps I just told you how to do, that's not conceptual. That's just rote, copying of things or regurgitating stuff. But understanding the concepts are very important for everything we do, honestly. So we're going to look at this numerically, which means we're looking at tables, and graphically, which is our pictures, and analytically, which is our equations. Okay. All right. So here are these tables. It says find the inverse relation of the given table. So let's call this one F. All right. If this is F, then this would be F inverse. And all we do to get the inverse is to switch x and y. So all of our x's become our y's, and all of our y's become our x's. And there's your inverse relation. Okay. So this original table right here, is this original table a function? Yes. How do we know for sure it's a function? Because the x values what? Don't repeat. Exactly. So I have y values that repeat, but that's okay. X values repeating, not okay. If you get that mixed up in your head, because depending on how it's worded, like I can word it weird where it's kind of said backwards and it can get confusing, and then that's when sometimes you think you know something, then you say it to yourself again, and then you second guess yourself, and then nothing makes sense, and you know what I'm saying, you'll get inside your head and you're going in circles. So if you look at this, you think, okay, well, I have something repeating and I don't remember if that one's good or bad. If I think about having, I don't need to make that little dot there. If I think about having a little graph here, right? So this point is at 3, 2. This point is at 6, 2. Well, it doesn't really look like it's at 2, but we can pretend, right? So that would totally be okay, right? That's totally okay that my y's repeat, not okay if my x's repeat, right? So the original table is a function because I have to fill in these blanks, I can't say because the x's don't repeat. That is a fine way to say it, to clearly understand the concept there, but we got to make sure we can say this a little bit differently. But it's because each x value has exactly one y value. Yes, that's fine. That's fine. And here, the reason x and y are okay is because they're literally labeled x and y, but input and output is totally fine too. But only if you write small in these blanks, I guess. All right, then it says however, so however kind of gives it away. So what do we think the answer is to the other one? No, okay. The inverse is not a function. And then so when you look at that over here, you go, all right, well, I got my x's repeating. So if I'm at 2, 3 and I'm at 2, 6, That's not okay, right? Because what do you think of here? How do you know? Besides the fact that the x's repeat, visually, what would tell you no? The vertical line test, right? Okay, so we're going to talk some about the vertical line test and about x's repeating and things like that, which are all very important concepts. Nobody taught you wrong. We need to know those things. But then this is why we have to have that basic concept, because we have to take that and fix our words some and say it. And this is one of those things that we have to say in a very specific way, unless we don't get our points, and we want to get our points. Okay, but so however, the inverse is not a function because, and we're going to be specific, the x value of 2 has 2 different y values. Okay. So all that makes sense to everybody. That's your basic understanding of inverses, right? Or inverses and functions, I guess. Okay, very good. Graphical. So let's look at these pictures. So it says to sketch the inverse relation of the given graph. So we're going to go by these steps over here. We have, we'll say that this one is f. And so we're going to make a little chart of our ordered pairs. Okay. And there are obviously an infinite amount of points, but I think if I just plotted 4 of them, I'd be good. So this one here is at -2, -1. This one is at -1, 2, 2, 1, and 4, 3. Okay. So then to find the inverse, looks like to the -1 power, right? Then all we do is switch our x and y. So switch your table around. Obviously, they have to stay matched up with the same number, but and then go and plot those points. Sometimes I can't hit the. Ugh. What did I do wrong? Oh, thank you. I did it twice. I even went back and fixed it. Thank you. What am I doing? Oh, I can't even read. Okay, thank you. I don't even know. I don't know what I was doing. Good Lord. Seeing if y'all are paying attention. Did I do this one right? Jeez. Oh, it's oh, that's why. I don't even know what I was doing. Okay, I'm so sorry, y'all. Holy crap. Okay, -1, -2, 2, -1, 1. Oh, so that point was right. Okay, I should have had a point there. So I don't even know where my brain went wrong. Is that correct now? I was so worried about, it's still not on the cross, but I ain't changing it again. I'm gonna mess it up again. All right, so then you got to be able to make sure that I'm still missing a point, aren't I? Okay, Jesus, all right. Then you got to make sure that you can connect the dots correctly, which I don't trust myself at all right now because I don't know what my brain's doing, but your ID makes a great straight edge. I'm going to cheat with my little line tool here, but I don't know why it's orange, but that's okay. And I connect the dots. And that was way more painful than it needed to be because that was really a very easy part of what we're supposed to be doing today. All right, so this is F. Oh, it's almost like it's a Monday. Okay, F, and this is F inverse. Okay, whew, that was rough. Okay, so all right, is the original relation a function? Yes. Okay, now we're gonna be very specific with our words. Okay, so we're gonna say that yes, F is a function, and they didn't name it F, I don't think, but I did, and so it's totally fine. And so I don't have to say the original relation. I named it, so it's totally fine. Is a function because And here's where we're going to switch our words to be a little bit more like what Charlotte said a minute ago. Because each input value is mapped. Okay, I've used this phrasing with you a few times, but you think of it as a mapping. I'm mapping this number to this number. Okay, literally like if you're looking at coordinates on a map, the same type of thing there. Okay, so yes, f is a function because each input value is mapped to a unique output value. Okay, so let's talk about how you could change those words a little bit and how you can't. So if you said, yes, the original relation is a function, and I don't know that I would use X and Y. We need to really stick with input and output when we're explaining ourselves. Input value, and up there we said has exactly one or something like that. I think that would be acceptable. I think it's better for you to be a little bit more formal. But instead of to a unique output value to exactly one output value, that's what unique means, right? So you can change the word as long as it has the same meaning there. You okay with that? We cannot say because it passes the vertical line test. Does it pass the vertical line test? Yes, and visually that can tell us this, but then we have to put it in our words like this. Okay, you okay with that? All right, and then it asks, is the inverse relation a function? Okay, is the inverse relation a function? What do we think? Yes? Are you sure the x's don't repeat? Look, I got x is 1, I got a point there, and I got a point here. It doesn't repeat in my chart, but I don't have every single point in my chart, right? If all I was given was this, was just the numbers, then my answer, the best I could say with my answer is no, it doesn't look like it. I mean, if we don't know it's continuous or anything like that. But this doesn't say, and this is where wording is important too. There's a lot of times we'll say, you have a table for selected values of x or something like that where it implies we're giving you some points but not all of them. Here it says find the inverse of the given table, of this table, and this is all the information we have. You with me on that? So be careful with that stuff because here, one of the things we can kind of think when we look at it visually is, I mean, there's more that repeats than that, right? That's totally, we got a few of them. But another one, if I wanted an actual point, I could say that like here, it looks like 3. Oh no, I'm looking at the wrong thing. I don't guess we need an actual point, but -1. Oh yeah, here we go. Wait, what am I trying to do? I'm sorry. No, I'm trying to think of, I was looking at the, I'm sorry. I was trying to talk about this, but what I really want to be talking about is the function. That was my whole next point of this. I know the way that this question is specifically asked, but I should have changed this because the way it's asked on the exam itself, it doesn't say, is the inverse relation a function? It says, does the function have an inverse? And that's different, right? Because here it's asking about the inverse. The way it's actually worded and the way we're going to word our answer is does the function have an inverse? And the answer is no, right? For the same reason as that this is the inverse is not a relation. We don't have an inverse function. I have an inverse, I don't have an inverse function. And then we talk about it through F, through what was given to me. So I cannot say that the inverse doesn't pass the horizontal line test. That wouldn't be okay anyway, but I'm not going to use that reason. Even if I could find this point, I wouldn't say this point, these have the same value. I need to talk about it with something else that I could use. All right. So if I use, and I'm still trying to use this point, that's why it was in my head. These 2 points here, right? Those 2 points, when you do your inverse, it's this one and this one. It just doesn't look like it because my inverse is bad. And I don't know why I just drew a line and I probably can't undo it. This one and this one, which I think somebody might have been saying to me. But these 2 points become these 2 points. All right. So here's how we word this. So we're going to say, F does not have an inverse function don't know why this graph is giving me so much trouble today. It's such a simple graph. Because, all right, and here's the best way to keep up with this. We're talking about the function the whole time. We're not actually talking about the inverse. We're talking about the function. The function is a function. The function does not have an inverse. And so what we looked at was each input is mapped to a unique output. Is every output mapped to a unique input or mapped from a unique input? And the answer to that is no, because of these 2 points here, right? The output of 2 is mapped from 2 different inputs. Therefore, when we take the inverse, that's what makes the inverse fail the vertical line test. You with me on that? So you basically just say it backwards from what we just said. F does not have an inverse function because each output value is not mapped from a unique input value. Okay. So yes, F is a function because each input value is mapped to a unique output value. That means my X's don't repeat. But the function does not have an inverse function because each output value is not mapped from a unique input value because my Y's do repeat. And then they also want you to have an example to say that F of -1 is equal to F of 3, which is equal to 2. Okay. So if your X's repeat, you don't have a function. If your Y's repeat, the function does not have an inverse. You with me on that? This is how, and this is wording that we're going to practice because I understand why they're trying to get you to say it this way because we have to make sure that we're relating back to what we were given and we were given the function, and that's a big thing in calculus as well. But they were very specific on this one point on the exam. It almost seemed a little too picky, but it is what it is. They don't care about our opinions, right? They don't care about my opinions, so we just got to get the wording down right. Any questions about what we're saying here? Okay, so in addition to that, what we need to know about inverses, okay, so this is our graphical property. It's down there at the very bottom there. Your graphical property of inverses. The graphs of inverses are blank over the line of blank. All right, so anybody know what goes in those blanks? A what? Reflection. Okay, do you see a reflection here? Do you see how we just reflected the original graph to get the new one? Okay, so our reflections, can anybody tell me over what line we're reflecting it in? The what? Okay, so if I'm not reflecting it in the y-axis or the x-axis, I think you're on the right track, but you don't know what to say, is what I think it is. What does the line look like? Y, what? Y equals x, yes. It is your parent function. It is y equals x right here. So this line is your y equals x. And it is just a reflection over that line. Because y'all were like, y, x, but I don't mean the axis. I don't know what I mean. But, and the reason is because you're switching x and y, right? You're switching x and y, so it reflects over y equals x. So just because y equals x. Think about how all that works together. All right, so over the line, y equals x. We can write that down here. All right, what questions do you have? Okay. Now let's actually do some inverse stuff, which is not that big of a deal, but holy heck, whew, I don't know why it's such a difficult thing sometimes. So we want to find the inverse. Gives us steps. We switch x and y, or our input and output, because it's not necessarily x and y. Solve for y and write it in the right form. So I would suggest we take f of x, we change it to y because we need to switch x and y, right? Then this will be x equals 3y minus 7. Now I got to solve for y. So I'm going to add 7 to both sides. Now, we want to work smarter, not harder, right? We don't have to absolutely reduce everything. We have to reduce more than you do in calculus. Y'all are going to love it when you get to calculus. You don't have to reduce anything. You don't have to simplify anything. But it's hard sometimes to learn to just stop. I could divide this out and I could get some fractions and stuff. Or if I just divide both sides by 3, I get x plus 7 over 3. I don't care if it's ugly. Did I get y by itself? I sure did. And then I don't have to worry about doing anything ridiculous if I make it any simpler than that. If you do make it simpler, it's not wrong, unless it's wrong, obviously. But I would just leave it, okay? So you've got y by itself. So now your answer then is f inverse of x equals x plus 7 over 3. Okay, everybody okay with that? Any questions at all? All right, so the inverse of a function is f inverse of x. We should know that notation. Okay, so then here are the steps to do it with rational functions. I'm not going to talk you through the steps. We're just going to do the steps, but they're there if you need them. So we're going to start by getting rid of f of x, making that y. Then I'm going to rewrite that as x equals y minus 2 over y plus 3. Okay. I need to get y by itself, but I have 2 y's over there. Can I cancel those y's out? No, that would make no sense, right? But I would like to get rid of the denominator. So I can get rid of the denominator by multiplying both sides by the denominator, right? Denominator has more than one term, so I got to make sure I put it in parentheses. So this will give me x times y plus 3 equals y minus 2. Well, that's a weird 2. Everybody with me? Okay, so I need to be able to get all my y's together, but there's a y trapped in here, so I need to distribute that x so I can do some other things. So I'm going to distribute the x, and I'm going to get x times y plus 3x equals y minus 2. And those of you that are insistent on skipping thousands of steps all over the place, these are the ones you get you in trouble, okay? Because you start to assume things or see things in your mind that aren't really happening. So just be very careful here. It's okay to skip steps in some situations. I wouldn't do a whole bunch here. Because what I'm trying to get by itself, what am I trying to get by itself? Y. So I need all my y's on one side, all my everything else on the other side. So I'll move all my y's to the left. Does it really matter? It doesn't matter. We'll go to the left. So I'm going to get xy. I'm going to subtract this y over here. But I need to move that 3x over there. So that'll give me negative 3x minus 2. So I did skip a step, which maybe some of you wouldn't even want to skip that step. That's okay. All right. Does everybody understand what I did, though, by skipping that step? I don't always like to skip steps up here. All right. What do you think I can do next? Since I need to get y, can I actually subtract these two terms and get one term? No. But what could I do here? Well, if I divide by x, I could divide by x. If I do that, it cancels this one out, but then this would give me y over x. And then I just get another fraction, right? So it was worth a shot, but it's just going to give me weirder stuff. What else could I do? So I just have one y. Factor it out. Factor out my y. And I get x minus 1. That leaves me with negative 3x minus 2. Then, what can I do now? Divide. So then y equals negative 3x minus 2 over x minus 1. So my answer then would be that f inverse of x is equal to negative 3x minus 2 over x minus 1. Right? Any questions at all? Could I have written this as, like when I moved my 3 over, could that have been negative 2 minus 3x? Yes, it's totally fine. There's different arrangements of that work just fine. All right. Any questions at all? All righty. Let's do this one. So I'm going to change this to y. Then I'm going to switch them. X equals 2y plus 1 over y minus 3. All right. You work on that one. So just have 3 people? Yeah, just trying to figure out who was absent. I'm going to keep writing, but don't follow me because it's probably not how you did it. Just keep doing your thing, okay? And then we'll talk about mine and we'll talk about yours. Oh, I'm left off something. Oh, look at me. I can't even distribute. Yeah, definitely don't follow me because I didn't even write this down right. Made a very rookie mistake right there. Okay. Okay. So I would assume, and maybe some of y'all did do it exactly the way I did it, but I would assume probably most of you moved your y's to the left like we did here, right? Which is 100% fine, right? And we always say if you do it differently, then we should get the exact same answer. Did y'all get the exact same answer I got? Some of you did. If you did, you moved your stuff to the right. If you didn't, you moved your stuff to the left. Okay. But here's what I want you to see is that by moving it to the right, what I got was, and this is g of x, so I got to make sure I call it the right there, g inverse of x rather. This is equal to negative 3x minus 1 over 2 minus x. So I'm going to do magic up here. I'm going to tell you what y'all got. Y'all would have got something like 3x plus 1 over x minus 2. Is that what you got? Okay. So when you solve this, depending on which side you move your stuff to, your answer could show up differently. So when you look at your answer key for this, I'll have both of those answers. I'm pretty sure I wrote them both. But the reason I'm pointing this out to you is, first of all, so you don't get in an argument with your neighbor. But second of all, if it is multiple choice and you get this and that answer isn't there, look at the difference. All the difference is you change every single sign. That's all it is. So here, my other option for this one would be f inverse of x equals 3x plus 2 over 1 minus x. Okay, that's another option for that one if it's a multiple choice type of thing. Okay, we good on that? Questions? Okay, great. Grab your other sheet of paper. This is going on 57 as well. All right, so we know that to find an inverse, we simply switch the x and y values, or the input and output, but you don't really have room to write those in there. Graphically, this means that the function and its inverse will be reflections over which line? Y equals x, right? So if a graph is not made up of simply line segments, sketching the inverse can be challenging. Like those inverses, we connected the dots on that last one, no big deal. So instead of trying to find the points and doing that, we think about them being reflections. And let's see, I thought there were some other words in here that I wanted. Oh, yeah. So check this out. Let's read these instructions, and then I'll tell you what we're really going to do. So we sketch the line y equals x on the graph, because that's our line of reflection. You mark any points from the original graph that are already on the line. Because if they're on the line, they stay on the line. They're just stuck to it, and you just think about it kind of like spinning around the line. These points stay the same. select a few additional points on the original graph to find their inverse points, because that should be easy to do. You can find the inverse points by switching x and y, which is what I suggest, or graphically reflecting each point over the line y equals x by drawing a line perpendicular okay, that is a long word. What is the symbol for perpendicular? Anybody know? It's like the upside down T, right? Perpendicular. That means perpendicular right there. Bam. You don't have to write the word every time. But you got to know what that means or it doesn't make any sense. So you draw a line perpendicular from the point to the line y equals x, extending it an equal distance on the other side of the line. Yuck. Okay, so you'd be doing this with a compass and a ruler and things like that. So we're not actually doing all that, but I'm going to show you why that works. That's a geometry concept that even if you didn't get all the tools out, you should have at least talked about. And then we sketch the graph. All right, here's what we're really going to do. We're going to cheat some because it's okay if it's not perfect, because this is not an art class and nobody's going to really make you do it by hand. But again, it's important to know the concepts of them. Okay, so the first thing it said to do was to sketch in the line y equals x. So I'm going to make it a dotted line. There's my line y equals x, even though I can't even hit that sometimes. Then it says to mark the points that are on the line, they are staying the same. So there's that point and that point. Those 2 points are on the line. Okay. Then I'm going to pick a couple of other points to find the inverse of. So I think this one here, which is at 0, 4, right? I have an actual point there. So that one I could make, actually, let me just go ahead and mark those. It'll be easier than me pointing at them. And then I'll use a different color. I think we can use those 5 points, right? Would you say those are good ones that we're not having to guess too much on the, all right. So then that 0, 4 is going to become what? 4, 0. And then 1, 1 stays 1, 1 because it's on the line. So that works. Except again, I can't hit the things right. All right, and then what does this one become? 0, 2. And this one becomes? This one, sorry. 1, 3. 1, 3 right here. And then, yeah, 4, 4 stays the same. All right, so just think about it. I mean, you've got the points there. So you should kind of see what's happening here, but you're taking this and you're reflecting it up. So what's happening is your parabola is just going to lay down. So then we just do our best to sketch it in. Oof. Close enough. But let me show you the draw a perpendicular line thing and what that was talking about. So on my original one, from this point, if I drew a line perpendicular to the line y equals x, and then I extend that line the same distance on the other side, so these are congruent and this is perpendicular, this point becomes this point. And that's true for every single point. So the same thing would happen here. Those two would be congruent. And that's how you could do it if you were trying to get it exact and you were trying to draw it by hand. That's what's happening. That's the definition of it, you know, geometrically. I want you to at least see that. Okay, we good? All right, so let's find some points here on this one. Actually, oh yeah. We don't need to draw another one. You're not going to have to draw them. I don't think it's necessary. I think we're going to skip that. All right, we're just going to skip that part. We don't need to do that. Okay, what do inverse functions do? If you plug a number, which really means substitute, you substitute a number into a function, it will generally output a new or different number. For example, if we plug x equals 2 into this function, what do we get? 5, okay? If we plug that answer into the inverse function, the answer should be 2, right? Because you're just undoing it, like multiplying by 2 and then dividing by 2 or something like that. This is because an inverse function will essentially undo a function. So if we plug x into a function and then plug the output into the inverse function, we should end up with x again. Make sense? Okay. So here's the definition of that. Two functions f and g are inverses if and only if f of g of x equals x and g of f of x equals x. And one of the things we looked at yesterday is f of g of x and g of f of x aren't always the same thing, right? But if they are the same thing and that thing is x, then they are inverses of each other. To write that in inverse notation, when we're talking about functions, we must show that if we substitute the inverse into f, okay, and substitute f into the inverse, both equal x. Here's the key word here. We must show. If it says show that these are inverses and you say they are not inverses, that makes no sense because they're telling you they are inverses and they're telling you you should get x. You just have to show the work that shows that that actually happens. Okay? Does that make sense to you? All right. So let f of x and g of x be the functions below. Determine if f of x and g of x are inverses. So we are going to we're going to do f of g of x. Okay? F of g of x. So I'm taking g of x, putting it in here. So that's going to equal 2 times 1/2 x plus 3/2 and then minus 3. Okay. When I distribute that 2 times 1/2 x is what? Yeah, just 1x plus what? 3, and then minus 3, and what do I get? X, which is what I expected to get, right? Well, actually, I didn't hear because it said determine. That's different. Determine. So I don't know if I'm getting x or not. Determine and show, two different things there. So now I'm going to do g of f of x. So I'm going to take f of x, put it in here. So that'll give me 1/2 times 2x minus 3 plus 3/2. So when I distribute my 1/2, that is going to give me x minus 3/2, then plus 3/2. That gives me x. So then, are they inverses? So yes, because f of g of x equals g of f of x, which equals x. Any questions about that? We good? Okie dokie. Now, sometimes we must use a restricted domain to ensure two functions are inverses, right? So we can't, this is defined for all real numbers. This is not defined for all real numbers, right? Because we could have imaginary numbers if we're taking the square root of a negative. So this is only true. They are inverses when x is greater than or equal to 10. And this says show. So we're going to show, which means I should get x, but I got to substitute them in. So I'm going to start with h of k of x. So k is going in here. So I'm going to get the square root of x minus 10 squared plus 10. Okay. So when I square the square root, what do I get? X minus 10, yeah. So I get x minus 10 and then plus 10. So I get x. Here, I totally expected to get that because it says show. If I didn't get it, I didn't do something right. Okay. Then I got to do k of h of x. So I'm going to have the square root of, and then everywhere I see an x, putting this in here, x squared plus 10 minus 10. Okay. So this is going to give me the square root of x squared, which is x. Or is it plus or minus x? Did we introduce the square root? No, that was part of it. If it's part of it, you do whatever it says. You only put plus or minus if you did it as part of solving. Okay, does that make sense? If I didn't put it there, it was already there. So that works too. So then I don't have to say yes necessarily. It said show. So I just showed that h of k of x equals k of h of x equals x. Okay. What questions you got? All right. You work on the last one while I hand out your assignments.
So this goes in every time you see.
Everywhere you see, so I put that everywhere I see an x, so it replaced that x right there. So instead of x minus 10, I get this minus 10.
Okay.
Yes? Okay. Okay, so I want you to finish that one up, and we are going to start here tomorrow, but you still have a few minutes left. I want you to actually finish this one, talk through it together, see where you can get with it. If you get stuck on n of p of x, try p of n of x. Okay, see what you can get done, but I want you to struggle through it.